Hi everyone, it's Mrs. Summer here to talk about Lesson 306, Balancing Equations, Day 2. The objective for today is that students will be able to model the law of conservation of mass by balancing chemical equations using coefficients. If you recall that chemical reactions occur when bonds between atoms are broken and new bonds form, they involve the making of new materials with new properties and energy changes. They are written as chemical equations. The coefficients tell you the number of each molecule. The subscripts tell you the number of each atom. The conservation of mass, or the conservation of matter, is matter cannot be created nor destroyed during a reaction. It is only rearranged. Because of this, a chemical equation must be balanced. If you recall, when balancing a chemical equation, you can add or change the coefficients, but you cannot add or change the subscripts. So steps to balancing an equation. So the first step is write the correct formula for the reactants and the products. Do not try to balance it yet. You must write the correct formulas first. And then once you write them correctly, do not change the formulas. So in this example, we have magnesium chlorate reacts to form magnesium chloride and oxygen. So I write MgClO3 2, and then reacts to form is my yield sign, magnesium chloride, MgCl2, plus oxygen. Now remember, oxygen is diatomic. It will only be found in nature connected to itself as O2. Step 2 was to draw a table under the reactants and products, and then find the number of atoms for each element on the left side of the reactants, and find the number of atoms on the right side, products, and then compare the two numbers. So on my reactant side, this yield sign did not get transferred over very well. I have 1 magnesium. I have 1, but then times 2, so I have 2 chlorines, and I have 3 times 2 is 6 oxygens. Now, on my product side, I have 1 magnesium, 2 chlorines, and 2 oxygens. Step 3 says to start placing coefficients in front of the formulas and retotal the number of each atom every time you place a coefficient. So if you notice, our magnesiums both have 1. Our chlorines both have 1. So the only thing that is not balanced at this time is our oxygen. Well, what can we put in front of oxygen to make the product side have 6? I can put a 3, because 3 times 2 is 6. So then I just need to check my answers. The number of atoms on both sides of the equation are now balanced, and the coefficients are in the lowest possible whole number ratios. So my magnesiums, yes, they're balanced. I have 1 and 1. My chlorines, I have 2 and 2. And my oxygens, I now have 6 and 6. So yes, this equation is now balanced, and the coefficients are in the lowest possible whole number ratios. So here's an example I want you to try on your own and type your answer into the Edpuzzle answer box when you are finished. Remember, you pause it. You can rewind to go back through the notes in the previous parts of the video. So in this example, we have sodium and water react to form sodium oxide and hydrogen. So I'm going to count my atoms. I have 1 sodium, 2 hydrogens, and 1 oxygen. On my product side, I have 2 sodiums, 2 hydrogens, and 1 oxygen. So now, remember, we want to balance everything else except for the hydrogens and oxygens, and then we'll do those last. So if we look at sodium, we need to put something in front of it. The product side has 2, but the reactant side only has 1. So I'm going to put a 2 in front of that sodium. And now I have 2 sodiums on the product, 2 hydrogens, 1 oxygen, 1 oxygen. So yes, it is balanced. So here's the answer again from the previous example.